Hi everyone, welcome to another stress lessons of chapter 9. Not really, so maximum and minimum is still fine. Later on, there will be a few sections that are making you stress. So I'll tell you what to do with it. Okay, so this section you still need to be paying attention. Alright, so turning point, maximum and minimum points. Okay, so these are the terms that you learn in SPM. Okay, turning point is a point in which the derivative change sign. So meaning that dy dx change from negative to positive or positive to negative. Okay, so dy dx positive to negative or negative to positive. Okay, the place where it changed the dy dx sign. Okay, you won't see it on the graph. You won't normally see it on the graph. Okay, unless you understand the whole thing. Okay, I'll explain that to you later on. So don't worry. Okay, so you see, you know what's dy dx? You know what's dy dx? Yes? Okay, dy dx means what? Dy dx means for this line, the dy dx at this point is this slope, right? Okay, slope. For this slope, is this, if the line is this way, slanted this way, means that the slope is positive. If it's slanted this way, means the slope is negative. Okay, remember that? Okay, it's okay. I just label label these lines for you first. Okay, this is line 1, this is line 2, this is line 3, this is line 4, this is line 5. Okay, then I have a table here. Line 1, 2, 3, 4, 5. Can you tell me what is the sign of dy dx for the first line? Just now I told you, right? If the line looks like this one, the line looks like this one, then it's positive. If the line looks like this, then it's negative. Okay, so the first line, it looks like this one. Okay, so it's positive. Second line, it still looks like this one. So it's positive. Okay, like I look at it here. Okay, so it's fine. So 3, how about 3? Can you tell me 3? 3 is a horizontal line. Horizontal line, what is the sign of dy dx? Smart guy, anyone? Anyone? Yes, the m is 0. Okay, because it's horizontal. Horizontal means no slope, right? No slope means m is 0. Okay, so the slope is 0. Okay, now, next one. When the line is this fourth line, the line looks like this one, right? So it's having a negative slope. So this changes to negative, and 5 is also negative, right? Okay, negative. So which one is the point where it changed the sign of dy dx? At the point? At here. This is the line where it changed, right? So here, look at the graph. On the graph itself is the point P. P is the middle point that it changed the sign, okay, sign of dy dx, right? Okay, then that point is called a turning point. Okay, that point is called a turning point. Sign changes from positive to negative at point P. Okay, you see that? From positive, then at this point is 0, then here is negative. That's why it's changed sign at the point P. And point P is the turning point. Okay, if you don't care about all these lines, you look at that thing here. What is this point? It's the highest point. So it's also called the local maximum point. In your book, you normally call it just a maximum point. It's there's no separation between local maximum point or what. But I'll just tell you here. Okay, it's local maximum point. It's not necessarily global maximum. Okay, but I'll just tell you that. Okay, so you want to name it as maximum point? It's okay. Maximum point. Okay. This is a turning point as well as a maximum point. Okay, turning point can be a maximum point, can be a minimum point. Okay, but yeah, so we'll just talk about this one later. Okay, so let's look at one more example. It's almost the same as the previous one. We got this line over here. Name all these lines. Okay, so now before I review, can you just tell me the dy dx changes from positive to negative or negative to positive? Think about it. Okay, right, I guess you get the answer. It's from negative, right, to positive, negative to positive at the point Q. Okay, let's see. 1, 2, 3, 4, 5. 1 having the having slope or the sign of dy dx to be negative, 0, positive, and positive. Okay, I guess you're good at this one already. Okay, you just need to know which way. This one means what? Negative. This one means positive. Great. Then it changes sign at point Q from negative to positive. Right. So point Q is a turning point because that's the point where it changes the sign, right? Okay, changes the sign of dy dx. Okay, and if you have this thing over here, okay, then what is that? The point in the bottom. It's a minimum point, or you call it local minimum point. So it's minimum point. Okay, so now you have learned 3 terms. One is turning point, second is maximum point, third is minimum point. Okay, great. So finding turning points and determine the type. So finding turning points. Set dy dx equals 0, then find x. Second, max or min. So you have to do what? To find turning point, very easy. You find set dy dx equals 0. You find a lot of x, maybe 1 or 2 or 3 maybe. Okay, so how do you know whether x equal 1 is a maximum point, minimum point, or something else? Okay, you have to find d square y, dx square. Okay, you have to find d square y, dx square. And then d square y, dx square, if it's greater than 0, then it means that it's a minimum point. Okay, then if it's less than 0, then it's a maximum point. So the thing is like a bit like the ballet, right? Okay, so this one is like minimum point is if it's greater than 0, maximum point if it's less than 0. Okay, just get to your mind. You need to remember this. Okay, so I give you one example here to show you what's happening here. Okay, so y is equal to x to the power 6, x power 2 minus 6x plus 3. Then dy dx, you know, 2x minus 6. You set it to be equal to 0. So then you can find 2x minus 6 is equal to 0. So 2x is equal to 6, x is equal to 3. You can you only find 1 point from this case. Okay, for other higher power one, you may be able to find more and more x. Okay, so x equal to 3 is a turning point. This from step 1, you can say that x equal to 3 is a turning point. Okay, all right. The next, d square y dx square is equal to 2. Okay, then sub x equal to 3 into d square y dx square. Okay, d square y dx square, you differentiate this dy dx. Okay, you get 2. It's a fixed function. It's a constant now, right? Okay, so you get 2. So you sub x equal to 3 into here 2. No matter what you sub in, it will give you 2. Okay, because it's a constant function already. So it's always greater than 0. Hence, it's a minimum. Okay, bigger than 0, minimum. If it's less than 0, then maximum. Just want to make one very small correction just now. I think I said it wrongly just now. Okay, I just like quickly say it out. Okay, so dy dx equals 0, x equals 3, then x is turning point. Not necessarily, to be frank. Okay, because you need to know when x equals 3 whether it is a maximum or minimum point or not. If it's not, then most likely it's not a turning point. Let's say I give you an example. Okay, you have a point here. Okay, then this one you will actually get the slope to be equal to 0, right? Let's say I draw the tangent line, draw it like this one. Okay, then the tangent line at this point will be 0. Okay, because it's a horizontal line. Okay, then you see here it's what? Negative, 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 and here is also negative, so it doesn't change sign from positive to negative. So here dy dx is equal to 0, but this one is not turning point. Okay, yeah. So you find turning point. What do you need to know is you differentiate, you get that answer, and you see whether it's a minimum or maximum point. If it's a minimum or maximum point, then definitely it's a turning point. Turning point has 2 nature. One is maximum, one is minimum. All right. All right. Next. So let y equals to 4x to the power 3 minus 18x squared minus 48x. Find the coordinate of all minimum and maximum point. Very simple. We just repeat whatever we have done. Okay. You find the dx. This one, I guess you are very good at this now. Okay. Set it to be equal to 0. Do you know how to solve this one? Set it to be equal to 0. There are a few ways, right? We have done it in chapter 2. You can use formula. You can use factorization. You can use completing a square. But now you see this one. you would just divide by 12 first. Then you see this one, okay, I think I can solve it by using factorization. So I'll just do it by factorization. So x equal 4 or x equal -1. And then these are most likely your turning point. Okay, I can't be sure now to tell you that it must be turning point because of what happened just now. Like what I said just now, that special function, the curve like that. Okay, at this point, dy dx is equal to 0, but it's not a turning point. Okay, so I won't be claiming that these are turning point at this moment. So we move on to verify that. Okay, so what do you need to do now? Second step is to find d square y dx square. Okay, d square y dx square means you take this one, differentiate, you get this one. Okay, you again, what do? You sub x equal 4 into here. When x equal 4, you sub it in, then you get something that you have to sub in now. Just now in the example that I gave you, you have nothing to sub, right? Because there's no x. Now, after differentiation, you're still left with some x. So you have to substitute in, then get 60. 60 is bigger than 0, hence it's a minimum. Okay, minimum. Bigger than 0 is minimum. Okay, less than 0 is maximum. Okay, if this one is minimum, it tells you that this one is a minimum point, and then you can say that x equal 4 is a turning point already now. Okay, normally your teacher won't be so rigorous about this one, but I'm just telling you so that you know more. Okay, right? Next, you have to sub x equal -1 into here. So then you get 960, which is less than 0. Hence, this point is a maximum point. But we are not done yet because we need to know all the points. Okay, by points, I think your teacher requires you to find the coordinate. So we find the y here. How do you find the y? Do you sub into d square y dx square? Do you sub into dy dx? No. You sub the point here 4 and -1 into the original function. Okay, then y is equal to -224. Okay, max when x equal to -1, you sub into this one, you get 26. 26. Okay. All right. Then max point is this one, this coordinate. Mean point is this one. Okay. Right. Then graph is given roughly here. Okay. This one, you know, the scale is different. If I give you the 1-to-1 scale, then it will look very flat. You see, here is 200, but here is 2 only. Okay. I just show you this one so that you can see what's happening on the graph. Okay. You see, this point here is what? -1. At this point, -1. Okay. This point here is this one. Okay. You see, this one is a maximum point and it's a turning point. You see, maximum point, if I draw this one, the slope will be 0. dy dx is equal to 0. Hence, you find this one here, right? Okay, dy dx equals 0. And here, this one also, the tangent line should have dy dx equals 0. The slope must be 0. Okay, and you see, this one from positive slope, change sign to negative slope. That's why this is turning point. Then this one, this is negative slope, slowly change to positive slope. Okay, if you don't understand what I say here, you can go back to the previous slide. Okay, but these are additional information to you. You don't really need to know it, but it's good that you know. Okay, right? All right, let's move on to the next one. Unknown turning point. So given the curve as turning point at x equal a, find a. Easy? Yes, because dy dx you just differentiate. You just let it be equal to 0. Then x is just 4. So your a is just 4. To be frank, this one is not a very good way to solve it, but then your SPM just requires you to do this. Okay, as long as you let dy dx equal 0, then it's a turning point. That's all the questions in SPM. Okay, although it might not be true, but the questions that you do, as long as you let it to equal 0 and you find the answer, then that's turning point. That's SPM. Okay. So you don't have to worry so much about, oh, say the equal 0, then it might not be a turning point, but I'm just telling you the real hard fact of the real life, okay? It might not be a turning point. You need to go and justify whether it's a turning point or not. Okay, but here, we just skip that part, okay? If you are more towards this one, then what you need to do is to find d square y dx square and sub this point in. If it's bigger than 0 or less than 0, then it's fine. It's either maximum or minimum point, so it's a turning point. Okay? If not, then it's fine. You can just give this one as your answer, you get full marks. Alright? Next, the curve y equal hx squared plus 2kx minus 2 has turning point, this one. Find h and k. Alright? So now, two things you need to remember. Turning point is when dy dx is equal to 0. And second one hidden in this question is telling you that turning point is a point on the graph or on the curve itself. So means that you substitute this one into here, left hand side must be equals to right hand side. If I give you these hints, can you try to do it? Okay, I hope you can try to do it. If you can, you pause the video and try this. If not, I'll just continue from here. Okay, so dy dx, you differentiate this one, you get this one. Okay, again, h is a constant, you put it outside. Then differentiate x squared, you get 2x. So it's 2hx. Then differentiate this one, 2k is a constant outside. Differentiate x is 1. So it's 2k only. Differentiate -2, of course, is 0. Okay, turning point at this one. So you set it to be equal to 0, you get x equals to 1. Okay, so x is equal to this one, which is equals to 1. Okay, only this one, okay, because you only need the x coordinate to find turning point. Okay, so you get an equation about h and k. So h is equal to -k. So I named that equation as 1, so it's easier to refer later. Okay, second information that I told you already is that turning point is a point on the curve. Okay, on the curve itself. So you sub x equal 1, y equal to -1 into here, left hand side will be equal to the right hand side. So sub this one into y, I get -1 is equal to this one. I arrange them nicely, so I get this equation 2. So I get two equations here. I use simultaneous equation to solve it. So I sub 1 into 2, I'll get k is equal to just 1. Okay, it's very simple. So k is equal to 1. If k is equal to 1, then h is equal to -k. So h is equal to -1. And I get my h and k. So very likely, this type of problem, very likely to be in your SPM. Always ask you to find h, k, p, q, a, b, and so on. Alright? So, no problem? No problem, then I move on. Okay, this is a little bit more difficult, right? You can expect this one to be a lot longer. Why? Because there are A, there are B, there are C. So, a few informations you need to take note. It passes through 1, 3. So, you sub that into here. You get left hand side equal right hand side. And has turning point, this one means you differentiate. You must set it to be equal to 0. Then it must be equal to -1. Okay, last one. Turning point, also a point on the curve. So sub this coordinate into that. Left has to be equal right. Okay, so I combine all this. So it could be very messy. So it's better you do it first, then you look at the answers. Because if not, you just look at this, you might be blank. Okay, okay. So I'll continue if you have done. All right. So y is equal to xy plus bx plus c. You sub x equal 1 into this one. Okay. So 3 is equal to a plus b plus c. No problem with this one, right? Okay. I sub 1 into here. Then left hand side and right hand side, I compare. So it's a plus b plus c equal 1. 3, sorry. That's, I name it to be equation 1. Then I differentiate. I make use of this property. Has turning point. I differentiate, I get this one. I set it to be equal to 0. Then I set it to be equal to 0. Then I get x equal to -1. So this one equals 0 and x equal to -1. So I will get this. Okay, b is equal to 2a. Okay. Okay, you have any problem with this? You know what I'm doing? I just sub -1 into here. So I get -2a plus b. No more x here. Okay, equals 0. So b is equal to 2a. So second equation. First equation, second equation. Okay, next. And I have to make use of the fact that this one is also a point on the curve. So, I sub when x equal to -1, y equal to 5, then 5 is equal to a minus b plus c. So this one I just put here, okay, the things here. I sub into the origin function. Right, then sub 2 into 1. So now I have these 3 equations and I have 3 unknowns. So it's something that's harder than your chapter 4, okay. So I just put this question here, possible. It's still a possible question in your SPM, okay? But maybe it's probably paper 2 if it happens. So this one, you need to solve these simultaneous equations. 3 variables and 3 unknowns. Okay? Sub 2 into 1, then you get this one. There are only 2 variables. And sub 2 into 3, 2 into 3, and you end up with these 2 variables again. So now you reduce 3 equations, 3 unknown questions to 2 equations, 2 unknowns. Okay? Then you can solve it easily. Maybe take 4 minus 5, or you can take A equals to C minus 5, sub into here to find C. Okay? So 2 minus 2 is equal to 4A, hence A is equal to negative half. I sub this negative half into either this one or this one. For this case, I sub into here. I get B is equal to this thing. Okay? Then I want to find C. I can sub into 5. Okay? I get C is equal to this. Then C is equal to this. And 902. So you get this. Okay? Right. So it's a bit tedious here. It's not difficult. Okay? Because you are solving equations, 3 equations, 3 unknowns. Okay? Just see whether you have any problem. If not, I'll move on. Okay? Right. So I just write this one down. I just write down this original one, although it's not required. Okay? Although it's not required, I just write down the original curve will look like this. Okay? They just ask you to find ABC, right? They just ask you to find ABC. This one, if you don't write, it's fine. Okay? Alright. So now it's homework time here. So pause the video and try this yourself. It's quite important, so I hope you can do it yourself. Alright, so I'll see you in the problem solving. Okay, let's get back to this and solve these problems. So first question, you find the coordinates of all maximum or minimum, differentiate, set it to be equal to 0. Find all the points here. You have 2 points here. Okay, you have 2 points. Then after that, you find the second derivative and just substitute these points inside and see if it's less than 0, then it's maximum, bigger than 0, minimum. Hence, you have to find all the coordinates of this. Coordinate means you have to find the y. Well, how do you find the y? You sub this x to the negative 3 and x equal 2 into the y, not into dy dx and not into d square y dx square. Okay? Check the answer and see if there's any problem. Right? No? Okay, B. Given that this curve has turning point at this one, find B. So in SPM, turning point means dy dx equals 0. Okay? Don't care about what I said just now, or previously. Okay? So you just need to know dy dx equals 0 is turning point in SPM. Okay? Other than that, you learn it in uni. Okay? So you differentiate this, you get 3a plus b. Because the 2 and 2 hands off, then 3x plus b, you set it to be equal to 0, x equal to negative b over 3. And the turning point is at x equal to 3, means this one is equal to 3. So you get b is equal to negative 9. Easy. Okay, C. Given that the curve, this one, has a turning point, this one. So definitely P and Q you need to find, right? Okay, P and Q. So dy dx, you get this one. Set it to be equal to 0, it's equal to Q. Okay, set it to be equal to 0, it's equals to Q. So these two are the same. Okay? Alright? So that's the meaning of turning point, right? Okay, sub x equal Q and equal to 3 and y equal 11 into the equations, because a turning point is also a point on the curve. So you sub into the curve, left hand side must be equal to right hand side. Hence, you'll get P is equal to 20. Okay, no problem. Last one. The curve has a turning point at this one. Find the values of A and B. Easy. Again, 2 information. Turning point, dy dx set is equal to 0, is equal to 2. Second, this one you sub into here, left hand side is equal to right hand side. 2 equations, and you solve for it. Okay, so differentiate, set it to be equal to 0. It's equal to b, negative BOA, negative BOA will be equals to 2. Okay, solve for it, you get 1 equation. Secondly, you sub these 2 into the original equation, you get another equation. I can name it to be 2. So you have 2 equations, 2 unknown, solving simultaneous equations. So you can sub 1 into 2, then you get A is equal to negative 2. Then you sub this back into 1, and you get B is equal to 4. So you get the answer, A is equal to negative 2, B is equal to 4. Alright, I'll see you in next class.